Welcome back to another episode of Learning by Doing OpenFOAM. Today's actually 9th of January 2025, so I'm not pretty sure if I'm allowed to say Happy New Year, but dang it, I'm going to say it anyway. So, Happy New Year to all of you. I hope that you're going to have a wonderful year ahead of you. Yeah, that's pretty much it. So, back to business. In the first episode of Learning by Doing OpenFOAM, we basically talked about compilation of OpenFOAM, the EC version or the ESI version of OpenFOAM from source code. It was version 2406. And it was pretty straightforward, I would say. And when I use straightforward, it means that relative to what we are going to try to do basically today, which is compilation of OpenFOAM from source code, but this time the Foundation version, another popular branch of OpenFOAM. And you're going to see that this is not as straightforward as what we had in EC version. And the reason for that is there has been basically conscious effort on the EC side to basically provide you now setup files that you can, without using those previous alternative ways, now you can compile the source code of OpenFOAM on your Mac machine. But on the basically the Foundation side, there hasn't been much of that effort, and but they do still have some alternative ways. Which, if you are interested, you can basically check their websites and see how you can have OpenFOAM Foundation on your Mac machine. But anyways, today's video is basically compilation from source code. And it's going to be a relatively long video because, my style that I don't pause videos. And apart from that, we're going to have a lot of back and forth and a lot of problems. I want to basically show everything. So fasten your seatbelts and let's just jump into the material for today. By the way, before basically starting, I want to say that part of the material, I basically don't want to reiterate myself. So probably you need to watch the first episode to basically know some stuff and some concepts. For example, things about the APFS, the Apple file system, if you want to make another volume, which is case sensitive, which is a requirement for compilation of OpenFOAM, and stuff of that nature. Probably you need to go back and watch the first episode. Anyways, as a continuation, basically, you should remember that we talked about Mr. Klein or Alexei, which is behind this account. And we talked about the EC OpenFOAM and Homebrew. And this one, in today's video, we're going to talk about the Foundation OpenFOAM and Homebrew. But I'm not going to use Homebrew, of course. And not much of the stuff. So there are some steps written here. And if you remember from the previous video, so first you need to create that volume, and then you need to basically mount it, and then you need to create this OpenFOAM directory in your home, and then you mount it into that directory, and then you cd into that, and then you download the proper OpenFOAM version, and then you cd into OpenFOAM, and you basically try to add these things into your prefs.sh. And you source the etc bash rc for OpenFOAM, and then you go for compilation. So, but this doesn't have something, and that something is the third-party libraries. So before doing this, you got to make sure that you have already installed the things that you want. For example, if you want OpenMPI, if you want Metis, Scotch, or Zoltan. So, I think we can start. I'm just trying to figure out how I need to basically grab. Okay, so we're going to start by downloading the source code. Probably that is the best idea. So we're going to say OpenFOAM 11 and GitHub. Yep. And then we're going to go click on the first link that shows up. So this is the source code. You can see OpenFOAM 11, and we're going to copy that. So I am in my home directory. I'm going to go to OpenFOAM. Again, this OpenFOAM directory is within an APFS volume. So if you don't know what that is, go back and watch the first episode. So here I'm going to say git clone, and I'm going to put that link, which I copied a second ago from here by clicking on this. It says copy URL to clipboard. So it's going to download OpenFOAM. And by the way, so Alexei, in the way that he basically put this, let's say, guidance or the document out there so that you can basically follow, is that he uses Brew to install those third-party libraries. But since I'm not going to use Brew, and on the other hand, I'm not also going to use the third-party library of which is shipped with OpenFOAM. So, for example, if you say third-party 11 GitHub, if you click on the first link, then again, this is third-party 11. So I'm not going to basically use this one, and you don't have to use this one as well. But for the sake of having that harmony, that we always have an OpenFOAM and we are having a third party alongside it, I'm going to put it there. But as I said, it's not mandatory. You can literally put another directory there, like a test directory, and then put all those third-party directories, all those third-party libraries that you want, for example, Metis, Scotch, or whatsoever, and then you can install them to any custom installation directory that you want, and then you need to basically edit some files, some configuration files inside OpenFOAM to be able to compile it in the end. So, but for the sake of having this harmony, for example, we are having OpenFOAM here and a third party with a version of it, I'm going to also download that one. So I'm going to say git clone, and I'm going to put the third party 11. Okay. So if you remember from the previous video, Alexei basically provides us some patch files. And this patch file, I'm going to click on that. So you see that for different versions of OpenFOAMs, he provides you patch files. And in today's video, as I said, I want to try OpenFOAM 11. So you see that we have this patch file. When you click on it, you see that bunch of pluses and minuses. And again, we talked about these stuff, what it means. But what is interesting is that there is sort of some letters here, some numbers and letters, and then it says .patch. So first you need to download this patch, which you can click on these three dots and then you say download. I already downloaded it to save up some time. I mean, it's very fast, but I already downloaded it anyway. But this thing is important. If I copy this, the text of it, and if I go back not to third party, but into OpenFOAM repository, and then here I jump and search inside this repository, this thing, and if I hit the return key, you see that 0 everywhere, but in commits, you see a 1. If you click on this, it shows that this is basically the hash. And you can copy full commit hash. If I click on that, so now it's copied into my clipboard. Now I can go inside OpenFOAM 11, and here what I can do is I can say git checkout, and I can also make a branch of it. For example, I don't know, test branch, and I can say the hash. So what this one is going to do is to basically revert into the status of this hash, and then it's going to also make a new branch as test branch. So if I hit the return key, you're going to see it says switch to a new branch, test branch. So if I say git status now, you're going to see it's on branch, test branch, and nothing to commit. So this is the status that we have. But we can copy from our downloads directory the kind of patch that we have basically downloaded, OpenFOAM 11 patch, to here. So I copy that here. Now I have the patch file here. So I can say git apply, and then I say the patch. I'm sorry. So I hit the return key. Now it seems like nothing has happened. But I want to draw your attention right here. If I say git status now, you see that lots of stuff has been modified. So there are things that are being added, there are things that are being basically modified, and you can see the list of things that have changed. And they appear in red, so we can go ahead and say, and there are also some untracked files, by the way. So some files were added into this sort of project. And And to be specific, for example, one of the important things is this config.csh or config.sh. This is the one that we are interested in. And there's a directory called Mac in there. And supposedly we're going to have some config files related to Mac. Okay, we're going to see that. And there also has been some files added into vmake rules, Darwin64 Clang. It makes sense because we are trying to compile it on a Darwin system. So let's git add everything, and I'm gonna say git commit, I don't know, a message like patch applied. I'm gonna do that. And then if I say git status, so you see that we applied all these stuff into a test branch, and we're good to go. So let's go into, for example, etc and then config.sh, and you're going to see a Mac directory. So here we have, for example, metis. Check this out. It says, it basically uses the functions, which is inside the current directory. And then it uses a function here, which is foam get package version, and then it gives the name metis for the version of metis and for the arch path of metis. A different function is being used is foam get package arch path. So let's go back to functions. And here you see, for example, get package version. It basically tries to, if you're having foam, if you are having brew, or if you are having port, the other one I think is port, if I'm not mistaken. Yeah, you have, if you are having brew or port, and through brew, homebrew or port, you are basically trying to install those third-party libraries like Metis, I don't know, Scotch or whatsoever. Yeah, so this is the solution, like some automated solution if you're using those stuff like homebrew or the Mac port. But today we're going to basically compile everything from source. So we're not going to use homebrew or MacPort or whatsoever. So we're going to change this stuff later. I'm not going to talk about this right now. I just wanted to draw your attention to that. And then you can also see, for example, in vmake, there's also these Darwin stuff added. For example, in C++, you see that these things are basically adapted into what we have for Mac operating system. And you see, I want to draw your attention to here. There's a point in this architecture here. We're going to talk about it later. So let's just go back. Yeah, let's go now to third-party 11. Here, we have a all vmake script here. So, and this all vmake script, you're going to have some setup files here. By default, when you download the third party, you have only this Scotch 609. So this is the basically source code of, you can see the source code of Scotch here. But I wanted to also add some 2 additional sort of things to basically compile alongside the compilation of other third-party libraries like Scotch. And I have downloaded those. In my downloads directory, I want to again add this metis. If you remember from my first episode, we also compiled metis alongside OpenFOAM in the previous episode. So I'm going to copy that into here. And on top of that, I'm going to also add Zoltan to here. And if you don't know what these things are, for example, here, again, this is not a, I don't know, I didn't take it from heaven, but this is the openfoam.org. This is the Foundation version. And if you go to this link, you're going to see that it says, for example, how you need to compile from source code and stuff like that. And here it says, for example, Scotch and PT Scotch and Zoltan are for domain decomposition and redistribution for parallel running. So Zoltan is being used basically for parallel load balancing, and then Scotch and PT Scotch are basically serial and parallel versions of basically decomposition, domain decomposition. And yeah, that's pretty much it. So now that I have put these things here, I'm gonna extract them. So we're gonna extract Zoltan here, and we're gonna extract also metis. So now we have 3 setup files. I'm gonna make just a directory called platforms. You can call it anything you want. There's not mandatory to call it as platforms. And I want to basically copy these directories the same way that they are written there. So I'm going to copy that. I'm going to make directory this. It's a new directory. It's empty. I'm not copying the content of that as just an empty directory. And I'm going to also create this directory, metis 510. And I'm going to make another one for Zoltan. Make directory Zoltan. So now we have these things, which, as I said, it's completely empty if I can type stuff. Now, let's go through compilation. We need the address. I want the address. Let's just start with Metis maybe. Metis is the easiest one. I'm going to copy pwd and copy this address because I want to install Metis into a custom installation directory. And I'm going to go to Metis source code. And I'm going to basically build this by saying make config shared equals 1. And prefix is going to be this thing, the address that I wanted. It was in platforms and Metis. I hit the return key. So it's going to do some stuff, and I'm going to say make. It's going to do some stuff. And then in the end, I'm going to say make install. Make install. So now if you go back to platforms, and if you check Metis, you're going to see, whoops, we're going to have a bin directory. Some binary files are in here. And in lib, you're going to have the lib Metis, the dynamic library. And then in include, you're going to have the header file of the Metis. So if you want, again, a permanent effect, you should be familiar with the path environment variable and also the LD library path and DILD library path. If you don't know what they are, again, please go back and watch the first episode of compilation of OpenFOAM, the EC version. But I already added these into my bash profile. So anyways, I'm going to go back. So now we can try Scotch, for example. So this is the address of this custom directory that I created. Now I'm going to go back into Scotch. This was basically provided by third party 11. So this is the source code. And if you open up, I think in this make file, yeah, here they talk about how you need to install this. So you need to pick one of the makefile.inc inside this make.inc. So I'm going to go into make.inc. And you're going to see that they have suggested a lot of different sort of make files depending on the architecture and the system that you have. For example, if it's Linux, if it's PC or whatsoever, like there are lots of variations here. But for Mac, there's two versions. There's i686 and Mac Darwin 10. And there's one version with ICC, the Intel compiler. And there's also a Darwin 8 version. So probably we should take the latest one. So I'm gonna copy from make.inc make file and then i68 Mac Darwin 10, and I want to copy it here, but I want to give it a name as makefile.inc. So now I have a makefile.inc, and these are basically the things that I need to put there. So you see that our libraries right now are being sort of static. We have the .a here. I'm going to change this to Clang, and I'm going to change this GCC also to Clang. And since we need also MPI here, I'm going to also add the include directory of my... Okay. Right now, you see that it complains about stuff because I'm sourcing in my bash profile. If I say tail minus n, I don't know, 3 lines in my bash profile, you see that I already sourced this OpenFOAM-v11 etc bash RC, and it complains about some stuff. But we are going to resolve these issues. But let's go into our downloads. And I think apps, and I think it was mpitch, and it was version 4, 2.2. And then it was install directory. Yes. I'm going to take that directory. And then I'm going to put here as include. So those are basically the header files. So I'm going to save this, and I'm going to also add in LD flags, I'm going to add the same address, but this time the lib for the libraries. And I'm going to also add lmpitch. So these are the changes you need to basically make. After that, you can save this file. And then what you need to do, basically, we can try by saying make libscotch. Let's try that. Okay, it's going to take some time. And now I'm going to say make lib ptscotch. Let's see if everything basically works fine. And let's do make scotch and make ptscotch. And let's do, so now we need the prefix here. So since I copied that one here, let me just copy that again in third party 11. And I think it was in platforms and it was scotch. I need this address for the prefix because we want to install it in a custom directory. So now I'm going to say make with prefix of that directory, and then I'm going to say install. And now if I go back, by the way, we're going to need hundreds of terminals today. So if I go back and here in platforms, again in Scotch, you're going to see that we have a binary directory, and we have include, and we have, I don't know, lib, and a lot of stuff. So these are the libraries, and they are static. Again, if you want a permanent effect, you're going to work with those environment variables. Again, the path and the LD library or die-LD library path, you're going to add them into your bash profile. Or if you're working with Linux, it should be the bash RC. And now finally, we're going to go to Zoltan. But maybe we can cheat also. Like if you check this all-vmake script here, if you search for Zoltan, you're going to see that there are some compilation things here. For example, it says Zoltan is optional, and then it gives you how basically you can compile. So I can basically use the same pattern here and try to build Zoltan. So let me open it here. Let's go to OpenFOAM and then third party 11. And then I'm going to go to all vmake, and then I'm going to search for Zoltan, and then I'm going to basically try to copy and paste everything here. But I need the address, so I'm going to go to platforms, and I'm going to go to Zoltan. I need this pwd, this address I need. So let's go now back. So this is the source code of Zoltan. I'm going to make a build directory, and I'm going to cd into that build directory, and I'm going to use configure with these things. So I'm going to have a prefix. So prefix, that's the custom installation directory. That's it. And then the lib directory, I think this should be sufficient. But I can also add it. It should be the same. I can add it under lib. And we should add with MPI. And then this is the MPI arch path, which is the path that I basically copied earlier, but I need to find it again. So I go to my downloads. It was apps, mpitch, and the version and the install directory. I need this. So I need to put the address of mpitch. By the way, if you're using OpenMPI, if you don't know how to compile mpitch from source code, I made already an episode about this compilation of mpitch from source code, and also compilation of OpenMPI from source code. So yeah, I don't want to. So this is where I basically, in a custom directory, I installed my mpage. So that is why I'm putting this directory here. You should put the same path for yours. And then we have with MPI compilers, no. So let's go with MPI compilers, no. And next thing is with MPI lib directory. Yeah. So with MPI lib directory, it should be this and then lib. And disable sollten CPP driver. I don't want to type that. I can copy and paste. I forgot about it. So just do that. And then we're going to have these two things as well. I'm going to copy that. Yeah. So I'm going to hit the return key. It's going to do some stuff for me. And then I'm going to say make everything. And then I should simply say make install. So for sollten, we basically did a little bit of cheating. Yeah. But by the way, you can also like check, for example, for Scotch, like there are also some stuff about how to compile Scotch. Yeah. You can follow things here, but this is the all vmake script. And as I said, we are not using basically this third-party 11. You can put all of these third-party libraries anywhere you like, and you can compile them separately. But to have that sort of harmony or coherency, we did that. So make install, the final touch. And now if we go back, we should basically in platforms in sollten, we should see an include directory, which has the header files. And then we should see a lib, which has the libsollten.a, again, another static library. So it seems like we got rid of all those static, not the static libraries, all those third-party libraries that we wanted. We have in total, you can say 4, because we have also mpeach, and we have sollten, we have metis, and we have Scotch. Okay, now we're good to go back into... But I need that address again. So let me go back to platforms. And here, I need this address pretty much. Yeah, we go back to OpenFOAM-v11. So we're going to go to etc. We're going to go to our config.sh. Inside Mac, you see that we have metis, and we go down here. You see that we are using this function foam-get package version, and as I said, I showed the functions already, and foam-get package version basically tries to check whether you have homebrew or whether you have port or whatsoever. So I want to get rid of this. So I'm going to delete this, and I'm going to put here metis, and then it was 510 if I'm not mistaken. Let's check it. Metis-510, exactly. I'm going to save it. And for the path, I'm going to delete this one too. And I'm going to put this path along with, basically, I can use this variable, metis version. So there we go. That's my arch path. And now I can go for example, Scotch, and do basically the same thing. So I'm going to put here, in order to prevent doing any typos, I'm just going to copy and paste that. And then I'm going to delete this one and copy this address. And I want to use basically this is Scotch version environment variable. Whoops. So I save it. So now we need one for sollten. We can copy it from the, because we don't have one here. So I'm going to copy that from here. And if you want to have sort of like the same harmony, you can also, no, never mind. Never mind. So this is just sollten 3.90. This is the correct version. But this thing, whoops, I made a mistake. This thing needs to be deleted. and I'm gonna put this, and I'm going to use also the same Zoltan version environment variable, because that's what we have here. So now we have Scotch, Zoltan, and Metis basically sorted out. Now we need to take care of MPI. So for MPI, if I go for system MPI, you see that we are basically exporting foam MPI as being MPI system, but this is not what I want. I want to basically have mpeach for 2.2. So that's what I want. And here I want to also add basically the things that I have in my this hidden OpenFOAM directory, and inside prefs, I'm going to basically copy everything for mpeach. Again, if you don't know what this prefs.sh is, you can maybe go back to the first episode and check all these stuff. But I'm going to basically copy everything into here. Going to go back here, close this file, and I'm going to get rid of all these ampersands. I'm going to shift this thing over. And so now you can see that foam MPI is basically, I can also remove this one because this is a duplicate. And then we have this arch path. Again, this is the custom installation directory that I have for my mpeach. And then the MPI root, MPI home, these are going to be just the copies of MPI arch path. And then the flags are going to be these flags. The include directories are going to be in arch path under the directory name of include. And then we're going to have the arch libs basically with capital -L, the address of the libraries. And then with the small l is the basically library itself. So it seems like we have taken care of this system MPI as well. And now going back again, I want to show my OpenFOAM and then prefs.sh. So here we are using the compiler type as system, and it's Clang on Mac operating system, of course. And then we are having we're compiling the optimized version of OpenFOAM. And then for MPI, for the mplib, this environment variable, vm mplib, we are using system MPI. And the reason for that is because we made those changes into system MPI. So yeah. And then I took all these stuff, I commented out these stuff because we added these Metis version or Metis arch path directly into that Mac directory. So yeah. So let's go back to OpenFOAM and OpenFOAM-v11. So I'm going to draw your attention. Pretty much, I think we took care of everything important, but there are some things left. If you try to compile OpenFOAM right now, there are going to be some troubles, but in the end, you can compile everything completely fine. But then when you want to test your OpenFOAM installation, you're going to run into this problem. So this is basically another thread. If you do some research, it's another thread that somebody like Surav Mandal, he tried to compile OpenFOAM version 9 on his MacBook M1 Pro. And then he said that he basically could, based on the instructions of Mr. Klein or Alexei, he basically could do the compilation, but he couldn't run block mesh because it says, for example, .ild and then symbol not found in flat namespace MPI abort. And you're going to say, the heck is that? So if you do more research, so here basically in this thread, they did not mention the real solution. They just mentioned that in another sort of GitHub page, you can go through an alternative solution. But the real solution is, I feel like, yeah, in here. It's in this GitHub Mr. Klein OpenFOAM OS X in the section issues and issues 91. You see that people talked about stuff and they figured out what the issue was behind of that flat namespace MPI abort or whatsoever. And this is basically a post by Philip Cardiff. Shout out to him as well. He says that you need to do some changes in the source code. And we are going to do that right now. So one of the things that you need to change is in vmake and rules. So I'm going to go to my source code, vmake, and then under rules, we have this Darwin. And under C++, you see that the architecture is x86-64. We're going to change this to ARM64 because we want to basically compile this on a M1. My machine is also M1, but these are specifically the ARM architecture of the new MacBooks. So I'm going to do this. And for the C as well, we're going to change this architecture to be ARM64. And I'm going to save that. And you see that this is the first thing that you need to do. Replace x86-64 with ARM64. And then do a vclean platform. We don't need to do that because we haven't compiled OpenFOAM yet. And then another change you need to do is in foam source, in OS specific. So let's go back. We're going to go back again, in source, in OS specific, cd OS specific, in POSIX. There's going to be this file called the SIG, is it inside signals? Probably yes. Yeah, a hack fix is line 41 in this line, OS specific POSIX signals and sigfpe.c. So sigfpe.c. So on line 41, you see that we have this include statement. He says you need to comment this out. This is what we did. And on line 215 and 216, so let's go to line 215 and 216, you need to comment these two out as well. So we're going to comment these two. This is like a hack fix. So what we are doing basically here is to basically resolve that issue of flat namespace MPI abort. I basically save up some time. But if you, without these changes, if you want to compile OpenFOAM, it's going to compile completely fine. But then once you want to test block mesh or test any solver, then you're going to run into that trouble, which is a little bit like cringe. You don't know what's wrong. And this is basically the problem that this guy also had in the past. But this is the real solution instead of following the other route, the one here mentioned. But anyways, so I think pretty much we have done everything related to every sort of settings or things that we needed to take care of before compilation of OpenFOAM. And now we should be able to say all we make. But before that, again, go back and source.bash profile. And now we should have access to those VM, for example, project directory. We check it. Yes, we do have access to that. Now we go to OpenFOAM and we go to OpenFOAM-v11. And here we simply are going to say all vmake and -j to use all the processes on our machine. And let the show basically begin. So you're going to see, it's not going to be as straightforward as I said. I promised that before, but let's see what happens as we continue doing this compilation. I need basically all these terminals because we're going to see problems that are popping. So I'm going to go to OpenFOAM-v11 here. I think I need to stay in source for one side, and for the other one, I should also go to OpenFOAM-v11. Let's keep them here and see. So this one is in source, and the other one is just in the main project directory. And let's, as you know my style, I never pause. So we basically need to stare into this screen of, yeah, stuff going up and down. So I'm going to drink some water. Yeah. Again, I want to shout out to all those people who contributed and made this possible. Okay, so this is basically the first thing that we need to take care of. Now, you see that a fatal error basically happens, and it says a Scotch decomp was not found. If you go back here and you say find name this Scotch decomp.h, you see in parallel. So I'm gonna keep it like that. I'm gonna copy that address. So that's the address. The file actually exists, but during the compilation, it says this file doesn't exist. But where did this error happen? This error happened when we were compiling this dummy scotch decomp.c. This is where it happened. And then on the other terminal, I want to find this dummy scotch decomp.c. And then you see inside source, inside dummy third party, inside scotch decomp, there's a make file. And if I go to make and options, so these are the addresses that I currently have, but I need to add this parallel, decompose, and scotch decomp. You see here we have parallel, decompose, scotch decomp with ln include, but I am going to add decompose, scotch decomp, and then I'm going to remove this. And I'm going to save that. So I'm going to save this. And I'm going to say all vmake minus j. So let's see if we basically resolve this issue. So we resolved that issue, but now it says it cannot find this decomposition method. And if I say find here name decomposition method, it is inside this address. You can copy it, or you can, but where did this error happen? It happened while it was trying to basically compile this dummy scotch decomp, the same .c file. So you got to go back to make options, and you're going to add another row here. I can basically get rid of these things and copy this and paste it in here. So this is basically that address in source, parallel, decompose, decomposition methods, and decomposition method. And inside that, you have this header file. So I'm going to save that file again, and I'm going to fire up all vmake minus j. And let's see. So now we got another issue. This is decomposition constraint. And if I find name that file, you see that it is inside this directory. I can't basically go towards the end. Oh my lord. I'm going to copy that. And then here, I'm going to in make options, I'm going to add this one as well. So I'm going to get rid of that. And then I'm going to paste the address which I copied from here. And then we are going to fire up all vmake minus j again. So this happened for scotch decomposition. And this is going to happen for all the other ones as well, for PT scotch and for metis as well. So find name and then this PT scotch. And this is going to be this address. But this time not in this make. I need to go back into PT scotch, and I need to add this to make options. And I'm going to copy that. And it was in decompose. Yeah, PT scotch. I hope that I don't make any typos here. And then I'm going to take these out as well. I'm gonna go save that. But before, if I do all vmake again, we're gonna see those constraints and those previous errors happening same in the same manner here. So what I'm going to do is to take it from the Scotch because we already added that into make options for them. So I think it was these extra 2 lines. I'm gonna take the same things and I'm gonna add them probably below this. Yes. I'm going to close that. And yeah, so now we have again those decomposition constraints or whatsoever. And we have also this, what was it called? Yeah, there were 2 things. I cannot pinpoint it right now. Did we make a mistake here? So we have PT Scotch decomp, and then we had, oh, I think we made a mistake here. I think we made a mistake. So let's go back into Scotch and make options. So what I wanted to have was basically this decomposition method, and I wanted to have the constraint as well. So I have the constraint here. I need to make it a little bit bigger. I think I messed up. Probably we should just go. Yeah, we have PT Scotch here. So before just ruining everything, because this is like a small window, I can't see properly like what was added in Scotch and then make options. So what I wanted to have was this decomposition method, and I wanted to have this decomposition constraint. These 2 lines I need. So I'm gonna say cat. I'm gonna say cat, and I'm gonna take these 2 lines because they're gonna happen in the same way as it happened for Scotch. So I'm gonna here in make options, I'm gonna add those 2 lines to here. So this should basically work. I hope that I didn't mess up this one. And there is this thing just to make it perfect. So let's try it. If it works fine, then it should basically complain about metas now. Yeah, so it worked fine. So again, we need these 2 lines, but on top of that, we need this file. So I'm gonna search for it, and this is the address. And then I'm gonna go back in metas decomp, and in this make options, I'm gonna add this line, and inside decompose, yes, here it should be metas decomp. And I'm gonna take these out. And then on top of that, I want to also add those 2 lines that I was talking about. So these 2 lines, because the same error happens if you do all vmake. So we're gonna save up some time. And here I want to basically paste that. And we just need to do the indentation right. And we save the file. We try to compile it again. And hopefully it should resolve the issue, and it should continue until it stops again because of another reasons. Okay. So I think we should move to applications. The next errors I think are happening inside applications, if I'm not mistaken. But we're gonna wait for it and see when it happens. So both of these are in application directory right now. But again, we need to stare at this screen. So you see that those things basically happened. Oh no, now Now that I remember, it happened for dummy Scotch and dummy Metis and dummy PT Scotch. It's gonna happen for Scotch and Metis and PT Scotch. So the same things needs to be added to another directory. So probably I need to back off and go back to source again, and here as well. Going back to source again. And let's see when that error happens. Okay, it might take some time. I don't know. We just need to wait. Gotta be patient. But basically the solution is the same, so maybe I should open up the, where was it, in parallel, decompose, and then it was in decomposition methods, if I'm not mistaken. Was it here? Options. No, it's not this one actually. I think it was in dummy something. Do we have any dummy decompositions somewhere? Dummy third party we have. Oh yeah, in dummy third party we had these. Okay. Yeah, so, and the same thing is going to happen for, you see that this thing basically happened already. It says it doesn't know where this decomposition method is, but this time it didn't happen for dummy Scotch. It actually happened while it was compiling this Scotch decomp.c. So what we are going to do is to basically find that. Where is, oops, where this file is. And then it says it's inside parallel, decompose, and Scotch decomp. So there is a high-level make directory here inside options. I need to add it basically here. Probably, yeah, anyways, I just need to delete this. And it should be in decomposition methods, right? Let's check it. So I'm going to go back and find that file. It's in decompose, decomposition methods, and decomposition method. So it should be decomposition methods, and inside decomposition method. I hope that I didn't make any typos in there. So we're going to try it and see if it resolved the issue. Okay, it resolved the issue, but now we need to also add this thing. This is also in decomposition methods, but inside decomposition constraints and inside this. So I'm going to copy that inside this make options. I'm going to copy that decomposition methods, and here I'm going to paste that line, and hopefully this should resolve the issue. All vmake minus j again. Now it is complaining about the same thing, decomposition method, but this is inside, this is for compilation of PT Scotch decomp. So we have resolved the issues here. So what I can do is to cat make options. This is the one for Scotch. and I can use basically these two lines. I copy them and I go back, but this time I do it for PT Scotch. Inside make and options, here I need to add those two lines. So I'm going to add those two lines. And since this is going to happen for Metis as well, I'm going to save up some time and I'm going to go to, oops, I made a mistake. I'm going to go to here, inside here, make options. I am going to add those two lines as well to save up some time. Otherwise, each time we need to say all v make and -j and see the same error happening. So hopefully it should resolve all the issues regarding the decomposition and load balancing stuff. Yeah, it seems like it's working now. Now the next error happens, I think, inside applications. So I'm going to switch into that directory. No, going back, applications, yes. So let's just wait and see the rest of the errors which are going to happen. So now you basically understand when I was talking about like the other one is relatively easier compared to this one. Now you see the hassle and basically step by step the problems are happening. And you need to basically fix them one by one. But hopefully, I hope that in the end, I'm going to get a working installation of OpenFOAM, the Foundation version, the version 11, and we're going to test it to make sure that we're not going to run into the same problem of that MPI abort couldn't be found in the flat namespace or whatsoever. The post which was mentioned in CFD online. Yeah. Yeah, maybe as it basically goes, I can recap what we did basically. So what you need to do in the beginning is to create that APFS volume, which I said I basically don't want to reiterate myself. You can watch the first episode and learn how basically you can do that. Or even if you don't want to watch the first episode, you can also take a look at Mr. Klein or Alexei's GitHub webpage when he talks about OpenFOAM Foundation and Homebrew, or OpenFOAM EC and Homebrew. You can, in that wiki page, you can basically find information about those APFS volumes. And then after that, you need to mount it. And once you mount it, you go inside that OpenFOAM directory. You try to clone the GitHub repository for any OpenFOAM version that you want. In this case, we used OpenFOAM-v11. The third-party 11, as I mentioned, I think I already stressed on that 3 times, it's not necessary. You can basically create any custom directory that you want, and you download any of the custom sort of third-party libraries that you want to compile alongside your OpenFOAM. And yeah, you're going to be good with that. But since we just wanted to have the harmony of OpenFOAM and third party on the other side, we just downloaded that one, and then inside that third party, we created that platforms directory, and then we basically put sort of directories for Metis, for Scotch and PT Scotch, and for Zoltan in the end. Yeah. And then what we did was basically, you can Google all of those. Like you can Google how to like download Scotch 609 or download Metis 510. And then you can basically download them and put them in that directory and then try to compile them from source. Of course, if you're using Brew or if you're using Mac port, it's going to be as easy as brew install, I don't know, Metis or whatsoever. But we basically compiled everything from source. Yeah, so you compile Scotch, and then you compile Metis, and then you compile Zoltan. And you saw that we basically cheated for Zoltan. We took a look at all vmake script and the kind of commands that was written there for compilation of Zoltan. Yeah. And then after those compilations, we went back to OpenFOAM source file, and we basically took a look at etc config.sh, and inside Mac directory there were like Metis, Scotch, and Zoltan. Zoltan was actually not there. We copied it from the previous directory, the parent directory, to that. And then we changed the way that it was basically taking the Arch path and also the version of each of those third-party libraries. We put the hard-coded ones, the ones that we basically compiled and put inside third-party and then platforms, and then each subdirectory for every library. And after that, we basically edited the file for MPI inside config.sh in MPI. We wanted to use system MPI, and then we added all those necessary environment variables regarding like the path for the libraries, the path for include directories, and whatsoever. And then after that, we said that we are set and we can source OpenFOAM, and then we can compile it, and it's going to compile completely fine. But then we said we're going to run into the problem of not finding that MPI abort, I don't know, in flat namespace or whatsoever, that error that I mentioned in CFD Online. And then we said the real solution for that is the hack that was mentioned in Alexei's GitHub webpage in issues 91. Yeah. And then we changed those things. The changes that we had to do was only two. We needed to go to basically remake rules, Starvin64, Clang, and then we needed to change C++ and C. We needed to change the architecture from x86-64 to ARM64, if you remember. And then after that, we basically went to OpenFOAM source directory in OS specific. And I think it was like somewhere in signals and SIG-FPE, the floating point exceptions. And then the hack was basically to comment out 3 lines. One include statement, and the other 2 was deep down in the code on lines 215 and 216, if I remember correctly. Yeah, and we saved that file, and then after that, it was just all vmake -j, and then we basically ran into some problems with the compiler not being able to find some of the source files, and we tried to basically, we had two side-by-side sort of these two side-by-side terminals to basically pinpoint where the error happened and what was the missing file. So on this left one, we were basically checking the missing file, and on the right terminal, we were checking where that source file that the compiler is trying to compile is located, and there is the parent make directory in there, and inside options, you can add all those include statements. And then we put the path of those files that were missing, that the compiler basically couldn't find, and the issue was resolved. And it happened, like the same pattern happened, and I tried to basically save up some time. It basically happens for all of those Scotch, PT Scotch, and Metis. Yeah. Now we are basically Okay, it says, what's the error now? The error is this interface. It says that it cannot find this file is not found, this interface surface tension. And if I find it inside my applications, name this, you see that the file already exists, but it just cannot find it. So and where did it happen? It did happen when it was trying to compile this, I think. Yes. So I'm going to find this file, and it is inside here. I'm going to cd into that, and you see that we have a parent make directory right here. There's lots and lots of stuff. Where should I put it? Yeah, I can try add those stuff here. So let's delete these. And by the way, I think so this is the source directory. And you need to go back. Oh, I made a mistake. You need to go back, and in applications, this address. I hope I did not mess it up, but it basically should resolve this issue. Let's see. Moment of truth. Yeah, it seems like it's working now. Okay, this is another one. Find name and this. So this thing also exists in here. And it happened when it was trying to compile this isothermal diameter. And as it happens, it's basically inside the same thing. So if I just want to show you to make sure that you get the idea. So if you search for this, then it is inside the same parent make directory. So inside this make options, you can add another line. I can take it from there. And then I can delete these. And then I'm going to say go back in applications, this. Oh, not that one. Not that one. Actually, the address is this one. And this should basically resolve this issue. There's -J. Let's hope for the best. So now it's working. It seems like it. So this is another issue. So I gotta find this file, and it actually exists inside this address. And where did it happen? It happened in fixed interfacial area diameter. So if I say find here, name, and then that, you see that it's in the same parent directory. So I'm going to use the same sort of options. I'm going to add it here. I'm going to delete these stuff. And then I'm going to say go back in applications, try to grab this address. I'm going to save that, and hopefully this should resolve the issue. Yeah. So far, Yeah, it seems like it's working now until it hits another error, which I'm pretty sure that it's gonna happen. There's always a catch. Yeah. Now we need to find this file. So I'm gonna find name. That file also exists inside this. And it happened when it was trying to compile as this binary breakup model. So if I search for this, you're going to see that it is in the same parent makefile directory, and then I'm going to use the same thing here. I'm going to use the same pattern. I'm going to delete these. I'm going to go back in applications, and I'm going to copy that address into here. I'm going to save this file. I'm going to say all vmake -j, and hopefully it's going to resolve the issue. Yeah, it seems like it's compiling now. So this is another problem. I gotta find this, name this file. It also exists. And it happened when it was trying to compile. I can't read. Yeah, this one. This binary breakup model, we already know that. So it's in the same. So I am going to add this in applications, and then I'm going to copy that and paste it here. And hopefully this should resolve the issue. Okay. Okay. Seems like it's not complaining anymore. But it should. It should. So that is when I'm talking like this is a pain in the ass. It's now you understand what I mean. I'm just gonna have a little bit of water. Okay. But this is a really, really long video. Oh my God. I'm sorry for that, but yeah, that's the style I basically chose. I could fast forward everything and show you the final product, but if you want to see every step of the way, this is the price you need to pay. This is the price you need to pay. Mm-hmm. Nice. Okay. So this seems like probably fine. Yeah. So congratulations. We made it to the end without any errors. Now the compilation is finished. Now, of course, we need to test it because you can't basically guarantee that this thing is gonna work. We hope that it's not gonna basically break. So let's just do a make directory -p with foam run. And let's just go back and go to our run directory. So this is our Einstein 11 run inside OpenFOAM. So I'm going to go to tutorials and I'm going to pick, I don't know, incompressible fluid. So let's test the third-party libraries that we installed. We installed Scotch, PT Scotch, or Zoltan, or stuff, Metis, or whatsoever. So I'm going to look for a case which has decompose pardict. I want a parallel case. So let's just pick one of them. Like, I don't know, this one maybe, the first one. Let's just go inside this directory. And let's take, it has an all run script that is super nice. I'm gonna get that and I'm gonna go to my run directory and copy that into there. And I am going to all run. So this is the serial version, the all run. So I'm going to hit the return key and let's see if it works. Actually, I made a mistake because I should have run this all run serial. But anyways, so we can all clean and do it again. So this should be all run serial to make sure that this thing works. So let's check when it seems like it worked. Foam run. Yeah, so it looks like basically did the simulation. And in block mesh, yeah, everything also here looks fine. So let's just do an all clean again and try to do an all run, but this time with parallel. And before doing that, let's check in system decompose pardict. Now we are using basically Scotch. So let's see if a Scotch works. Moment of truth. All run parallel. So now you see that it says it's using 4 processes on my machine. And it seemed like everything, yeah, we do have the processor directories. And let's take a look at, for example, decompose par, the log file. It says that it tries the decomposer Scotch and everything looks fine. And for the foam run, hopefully we have results here. Yes. And what we can do now is to basically do a all clean. I want to also test if we do, instead of Scotch, if we do Metis. Is it going to basically work because we also compiled metas alongside our OpenFOAM installation. So let's try it. We'll run parallel. Wow, it was fast. So let's go to log decompose par. Okay, so it says, so we have a problem here. It says you are trying to use metas, but you don't have metas decomp library loaded. Okay, apparently. Okay. So this should be something like if I go to my let's find here the name of metas decomp, and it happens in source and in parallel, in decompose, and in metas decomp. So if I say inside make and options, you see that we have metas arch path include and these sort of things here. And inside files, we have this lib metas decomp that we currently don't have it, and it should be inside this foam lib bin. So in the other one, I want to show basically that we don't have that one. So foam lib bin. So if I go into that, so apparently here inside this mpich, so inside mpich, we do have pstream and basically the pt scotch decomp. So that is why the scotch basically worked. But what we are lacking here is basically we don't have this lib metas decomp. So if I say, I don't know, like vim lib metas decomp, the tab doesn't work, the tab completion. So what I can do is to say vmake here and see what the problem is. It says that it cannot find the metas.h, but we are pretty sure that we compiled this. So let's go to third party 11. Let's go to platforms and let's go to metas. And let's go to our include directory. So metas.h is located here. So what I'm going to do is, let's see, in make options, you see that we are using metas arch path, and then we are using this include. So this means if I copy this without the include, if I export metas arch path as this address, then it means that I can say vmake, because it should be able to compile this. And now it works. And now to show basically that it worked, we go back to libbin and let's take a look at lib metas. Now you see that metas decomp is right there, like a champ. So if we go back in all clean, and now if we say all run parallel, hopefully it should work. Let's take a look at decompose par. And it worked like a champ. Yeah, selecting decomposer as metas, and yep, beautiful. Now we basically proved that we have a working installation of OpenFOAM. But wait, before leaving, before basically dismissing this video, we need to test one more thing, because we also added Zoltan, and I'm not 100% sure that. So let's go back to tutorials and let's go to incompressible fluid. Let's, should I grab it like Zoltan? Yeah, there is an example here. So in this motorbike steady, can I type that, bro? Please. Okay. So I'm gonna copy that. I'm gonna go to my run, copy that case to here inside motorbike, and you see that in system decompose power, we have hierarchical with PT Scotch. We can test that one whether it works. So let's go with all run and see if hierarchical alongside with PT Scotch works. So this time we are using 6 processes, and it should basically work fine. So this is fine, and the foam run also, yeah, it is also fine. So now you see that it's foam run dash parallel. We used 6 processes and 1 master processor, and 5 of them are basically slaves. Let's do an all clean. So another moment of truth is that if we change this, so decomposer, let's leave that one and let's take these 2 out. So instead of this distributor being PT Scotch, I want to try to use Zoltan, and let's see if this one works. So we do an all run. Let's take a look at the results. So if we go to decompose par, it seems that, oh, it seems that a problem is here. It says that this library lib Zoltan decomp dylib, this dynamic library, he tried basically all these addresses and it couldn't find that library, unfortunately. So it seems like, again, we're going to go back to the source code. Let's go back to OpenFOAM and then OpenFOAM here, 11. So probably we need that. I'm going to grab it. So there should be some resultant.h. Maybe I should have tried it inside source. Let's go to source and grab it again. So yeah, it does happen in parallel. Decompose, and then let's go to Zoltan decomp, and this is our make. Options, you see that, oh, again, the same problem probably. This Zoltan arch path is not defined. That's my assumption. So if I say vmake, yeah. Oh, but this is different. It says MPI is not found. So in make options, that is very strange. It says MPI lib type. I don't know. That is actually very strange. Yeah. Okay, anyways. So in source PStream MPI. Okay. So let's try this with okay, MPIH was not found. But I'm pretty sure also we have this issue with Zoltan arch path. This is not probably defined. So I'm gonna quit that and echo this. Yeah, we don't have that. So let's add these 2. It was in OpenFOAM and then third party 11 and then in platforms, and then we had Zoltan. So this should be the arch path. So I am going to actually define that here. Should I? Okay, let's try it. So let's export that Zoltan arch path. Zoltan. Oh, I made a mistake. Oh my lord. Export Zoltan arch path as this, and then it should basically make options. Yeah, it's trying to retrieve those files from include. So if I say vmake, it should still complain about this mpi.h, which this one should be in my downloads, apps, mpeach, this one, and install directory here. Not in libs, but in include, there's this mpi.h. So I am going to add this directory and make options. Let's see if it works. So I'm going to add this, and let's see, vmake. Okay, seems like it worked. I'm going to libbin again to check whether that thing. Oh, probably we made a mistake, because now I understand. It's, I don't know, but let's see where this thing is basically in files. Yeah, the Foam API is probably not set correctly. Let me echo that. Foam API. So Foam MPI, I'm tripping. Yeah, that's the problem. That's the problem. That's MPI system, unfortunately. And we basically combined it also there. Oh my lord. MPI system. So now you see that this Sultan decomp is actually put in there, while it should be in mpeach 4.2.2. But yeah. So let me echo the same environment variable here, like foam MPI. So here it's set correctly as mpeach. I don't know, like we can also copy that or move that to there, like copy MPI system, this library into mpeach. Yeah. And now inside this mpeach, we have also this libzoltan decomp. And hopefully it should work now. All clean. And all run. Let's see. Okay, it's taking longer, so I'm happy because it seems like it's running fine. Yeah. Now I understand why this happened. The reason is because I opened these parallel terminals, and this terminal was aware that I'm using system MPI, as MPI is not MPI system, but I changed it to mpeach 4.2.2, but the other terminal didn't know that. So that is why, and I tried to compile both of those libraries, Metis and also the other one on this terminal on the left. That is why that problem happened. So I can safely basically remove that directory as well, like this MPI system inside foam libbin, because everything should be inside this mpeach 4.2.2. But it seems like it's working completely fine. So you see, again, that's my point. So you got to test everything. Like you might think that you compiled everything, all those third-party libraries and everything. But then once you try to test things, then you see that everything basically crumbles, and you need to figure out that the compiler has access to all sort of the libraries and include directories, you know. Most of the times, like these are the errors that happen. But for some reason, it's taking much longer on Zoltan. I don't know why, because the other one was pretty fast. I don't know what is wrong, but we can also check from other terminal, like in OpenFOAM and Einstein 11. So in run, and it's motorbike steady. Let's take a look at the decompose par. Oh yeah, now it works. Now it works completely fine. Yeah, there's no error that it cannot find that leap Zoltan decompose whatsoever. And this foam run, yeah, here also looks fine. Yeah, we do have results. Okay, very solid. So we tried system decompose par. We tried basically hierarchical with distributed Zoltan, and then we also imported this libzoltan decomp.so. And by the way, this shouldn't be actually .so, it should be .dilib, so dilib. So that's what it should be, because once we compiled that in foam libin, so inside mpeach, it's actually libzoltan decomp dilib. It's not a .so. So yeah, but we tested lots of stuff. We tested Scotch, we tested PT Scotch, we tested Metis, and we tested also Zoltan, and all of these are working fine. So there we go. Congratulations on compiling OpenFOAM Foundation version 11 on your Mac operating system. I hope you learned something from this video, and I hope to see you in the next one.